Surface tension occurs because molecules of a liquid attract one another. The attractive force between similar molecules is called cohesive force. Cohesive forces inside the liquid are cancelled out, so interior molecules have a low energy state. However, boundary molecules have a high energy state, as cohesive forces are not cancelled out on the surface of the liquid. Consequently, in accordance with the principle of minimum energy, the boundary molecules are pulled constantly towards the inside of the liquid. As a result, it attempts to obtain the smallest surface area possible. This is why a free-falling water droplet takes the shape of a sphere. The phenomenon of surface tension becomes more complex when molecules of a solid surface interact with the liquid. The attractive force between the molecules of a solid surface and those of a liquid is called adhesive force. Wetting is a characteristic ability of a particular liquid-solid pair which depends on the magnitude of the adhesive force and the cohesive force between the molecules of a liquid. If this force is strong enough, the liquid spreads on the solid surface. In other words, it is capable of wetting it. However, if the adhesive force is weak, the liquid in contact with the solid surface can reduce its own surface area, and no wetting occurs. Mercury, for instance, is a non-wetting liquid. The wetting ability of liquids determines how they behave in thin tubes, that is, capillaries. The law of communicating vessels does not apply to liquids in capillary tubes, meaning that the liquid is not on the same level in these tubes. Instead, capillary action can be observed. A capillary containing water exhibits capillary rise, while a capillary containing mercury exhibits capillary fall. Capillary rise occurs when the liquid wets the wall of the tube, that is, when the adhesive forces between the tube and the liquid are stronger than the cohesive forces between the water molecules. If it is the other way round, capillary fall happens. Surface tension and capillary action play an important role in nature. For example, pond skaters could not run on the surface of the water without the presence of surface tension. The legs of these aquatic insects are covered with tiny hairs, which provide a small surface area, thus making them non-wettable. Due to the surface tension, the surface of the water acts like a membrane that can support the weight of pond skaters, and tiny depressions form on the water under their legs. They can launch themselves from these depressions, reaching speeds of up to 90 centimeters per second.